Okay, this is the second part of section 1.4. Sorry. And we are still talking about continuity and what makes those pieces important. And the new piece today is going to be called IVT, the Intermediate Value Theorem. So we are mainly going to be working from page 77 in your book. So today you'll need your book and to follow with your notes. Now then, after we finish this video, I want you to go back and fill in these notes we'll go over on Wednesday during class. What do you think the definition of continuity is, in your words, or refer to the notes we've already completed? And then what is definition of continuity at a point? And that's specific. There should be three things. The types of discontinuity, and sketch a graph. So name the discontinuity and a graph to match it. We're going to compare these on Wednesday. What determines the existence of a limit at a function at x equals c? And which worksheet we're going to do in class on Wednesday. And what determines continuity on a closed interval? We've got continuity at point and continuity on a closed interval. But for your assignment after your quiz, or assignment for Tuesday during class, you're going to need, you're going to need to know about the intermediate value theorem. So you've been exposed to it in pre-calculus, I believe. So let's talk a little bit more about how we're going to use it in calculus. This is one of the most important theorems, and it's a continual theme throughout the year. They're going to ask you about a value in a closed interval where the function is continuous. And this is one of the first of what they call the existence theorems. Existence theorems are a major topic on the AB exam in May. So this is existence theorem number 1. And we call it IVT, Intermediate Value Theorem. Then there's EVT, Extreme Value Theorem, and then there's MVT, Mean Value Theorem. There are 3 existence theorems that we mainly use, and then there's one more called Rolle's Theorem. And we'll be using all 3 within a month, and you got to know how to use all 3 differently. Okay, so intermediate value theorem, these conditions have to exist in order for you to use it, and this is what they're testing you on. Can you recognize these conditions are true in order for you to use this theorem? Again, this is talking about existence of something, not necessarily finding a value, and that's what makes it kind of vague. If f is continuous on the closed interval a and b, we just talked about continuity on a closed interval, and k is any number between f of a and f of b, then there is at least one number c in a at closed interval a and b such that f is equals k. Kind of interesting. It says a lot. So what needs to be true about f of x? It needs to be continuous on f of x. And what does that mean? So write in your words what you think that means. Hopefully you're saying something like f of x is defined for all values between a and b and defined at x equals a and x equals b. Something like that. Okay, so if we know that it's continuous on the closed interval, and another condition has to exist. There is a number k between f of a and f of b. So let's say if f of a was 6 and f of b was 8, then k would have to be some number between 6 and 8. then there is at least one number c such that f of c equals k. So two things you have to recognize: that it's continuous function, continuous on a closed interval, and that k is between the values of the y values of the endpoints. All right, so let's see how we can use it in this information. Use the intermediate value theorem to find a value c in the indicated interval. So first we're going to use it so we can find c, so that f of c equals 4. All right, so let's first find f of 0. And let's just determine our endpoints. F of 0 is equal to 2. And what is f of 4? I'm going to just check my work in my head. Which is 14. And we need to check, is 4 between 2 and 14? Because otherwise the intermediate value theorem will not apply. That's one of those conditions, and yes, 4 is between 2 and 14. The other condition is that f of x has to be continuous. Is this function continuous from 0 to 4? Well, yeah, it's just a parabola. It's just a quadratic. It doesn't have any discontinuity, so we're good. So now we're going to determine, is there an x that will make this function equal to 4? So x squared minus x plus 2, is that equal to 4? Well, that looks like a good old quadratic. So let's just subtract 4 from both sides. And we get x minus 2, x minus 1 equals 0. So x can be 2 or x can equal 1. Can it be two different values? All right, let's test that. Let's see if that makes a true statement. So go to your calculator, go to your y equals key, clear out any functions that are in there. All right. And let's type in the function given to us, x squared minus x plus 2. Go to your window. Let's make it a nice window. We're only looking between 0 and 4, so let's let our x min be -1. Our x max be 5. Let's let our x scale be 0.5. All right, this is a function. This is a quadratic. Its y-intercept is 2, so let's let our y min be -2. That's good. And our y max, let's go to 8, and let our y scale be 0.5. Let's graph that. So here's a nice little parabola. And we only want to look what happens between 0 and 4. And we're looking to see where is equal to 4. So let's go to your y equals key. And for the second function, let's plug in 4. Let's graph that. All right. So it looks like I factored incorrectly. Let me go back and correct my work. You probably picked up on it. So this should be a plus here. So x equals -1 or x equals 2. Good thing we checked it. All right. So is -1 in the interval between 0 and 4? No, it's not. So I cannot let it equal -1. So the only value for c is going to be x equals 2. Good thing that you guys probably picked up on I factored incorrectly, but as you can see, I want to go back and check my work. One way I checked it was I confirmed the graph on the calculator, if that's allowable. All right. Sometimes we use IFT to determine if there's a 0 in a designated interval of a function. How would you determine if it can tell you that there is a 0? Not what the value is, but is there a 0? In other words, does a 0 of the function exist in a designated interval? How can IVT help you with that? Write a sentence there, and we'll talk about that at the next class meeting. All right, let's look at the next page. If f of x is continuous from -2 to 6 and f of -1 is equal to 5, f of 2 -3, is there a value c such that in the interval f of negative from -2 to 6, so f of c is equal to 0. It didn't ask me what the value of c was. It just said, can there be a place so that then when I plug c in for this particular function, I can get 0. All right, well, first of all, is it continuous? Second, is 0 between 5 and -3? Well, it told me it's continuous, so yes, it meets that condition. 0 is between 5 and -3. So that means that I can use IVT. And since 0 is between 5 and -3, then there exists at least one value, C, such that f of c equals 0. You just used IVT to show that a 0 function exists. All right, read this next question. Write down what your answer is, and we're going to talk about it at the beginning of class, at our next class meeting.